Okay, this is a antiderivative. It's pretty simple, and I've also, but I know we're just starting out, so I've put the some anti-differentiation rules over here and properties. And the first one says that if I have the antiderivative of a constant times a function, then I can pull that constant out in front and take the antiderivative that way. The constant kind of goes along for the ride, I've heard it said. The next one says if I have the antiderivative of a sum of difference of functions, then that actually equals the antiderivative of the individual functions that I have the sum or difference of. So, like in this case, I have the antiderivative of 5 minus 6x, so I have the function 5 and 6x, and I have a difference of the two, so that means that I can actually go in here and I can rewrite this integral with that second property there as the antiderivative of 5 with respect to x minus the antiderivative of 6x with respect to x. And then with the first property, I can bring those constants out in front. Although I'm not going to do this all the time. In fact, I'll and you won't either, because you'll get at the point where something like this, you'll just do this automatically. But anyway, the first property tells us that we can pull those constants out in front. So we have here we have 5, and you don't really have to write that 1 there. A lot of times they just write the integral symbol and then dx. But anyway, so we have 5 times the integral of 1 dx minus, we can bring that 6 out in front, the integral minus 6 times the integral, indefinite integral of x dx. And now we can pretty much use the third. This is pretty much the rule, the power rule for antidifferentiation. It says if as long as x has a power of anything but -1, we can say that the antiderivative of that is x to the power to the power it originally was plus 1 over the new power plus an arbitrary constant. You may say, well, there's no x in this first one. Well, there's x to the 0, and x to the 0 is 1. So if we say 5, so if we antidifferentiate and we say 5 times the antiderivative of 1 is x, the original power plus 1, so that's 0 plus 1 over the new power, which is 0 plus 1, and you certainly won't do this. This is way too much detail to be practical, but for this example I'm showing you. And then the next one is -6, and then we want to take that, there's a original power of 1 on that x, so we want to add 1 to it. Excuse me. And we want to put it over the new power. What I was debating is whether I should put a plus, since I broke it up, I should have put a plus c, but I'm not. So arbitrary constant plus an arbitrary constant is just another arbitrary constant. That's why it's not really necessary. We'll clean this up a little bit because it doesn't really look very normal. So we have 5x as our first expression because this is just 5x over 1 in the first place. And then we have -6 times x to the 1 plus 1 is 2 over 2, and then plus c. And then finally we have 5x, and then -6 over 2 is just -3 x squared plus c. And that's pretty much, well, that isn't pretty much it. That is it. And honestly, in the future, we'll probably just say, oh, we'll just apply these, just knowing those things. But you can do this, and starting off with, it's sometimes helpful to get those kind of rules in your mind to kind of write out all the steps. But in the future, we're just going to kind of say that, well, that equals the antiderivative of 5 is 5x minus 6x squared over 2 plus c. And then we'll just go back in there and write a 3 there, and rewrite it neatly. And then when you get good enough, you probably won't even put this 2 under there. But although a lot of people keep on doing that because you can make a mistake pretty easily. So that's it.